In this video, we're going to look at the slope of a tangent line. So let's start by talking about what a tangent line is. So let's define a tangent line to be a line that touches a curve at a single point. Say, for example, that our curve looks like this. Let's say we're looking at this point right here. Then our tangent line might look a little something like that. So it's a line that comes in, just touches our curve at a single point. Now, if we want a way of writing down the slope of the tangent line, then we're going to use the notation m with a subscript of tan to represent that slope. M is the familiar notation for slope, so when we write m tan, that means slope of the tangent line. So let's work towards figuring out a formula for the slope of a tangent line. Let's look at this little discussion here. So let's consider a short line segment, PQ, where P and Q are 2 points that are on our curve. So I'm just going to draw another sketch on the side here. Let's say this is our curve. Let's say that's called y equals f of x. And we'll take any 2 points, say P and Q, that lie on that curve there. And what we're interested in is looking at the line segment between P and Q. So there's our line segment there. Now let's imagine that these points P and Q are close together. So we're going to let little h be a small positive number. So you can imagine something like h equal 0.1 or h equal 0.01 for the sake of this discussion. So if we want to represent the fact that P and Q are close together, then we could start to think about the coordinates of P and Q. And we can say, well, if P has an x value of x, then the x coordinate of Q could be something like x plus h. So the fact that h is a small number is just like saying these 2 points are close together. Their x coordinates are pretty close. And then if we wanted to figure out the y coordinates of these points, well, we would just look back at our curve and we'd say our curve has the formula y equal f of x. So a point that has x value of x is going to have y value f of x. And a point that has a point like Q that has an x value of x plus h, its y value is going to be f of x plus h. So that's how we're able to figure out the coordinates here for P and Q. So we're going to redraw this diagram in a minute. And based on that diagram, we're going to see if we can figure out the slope of the line segment PQ. Once we've got the slope of PQ, then we'll be able to talk about the slope of the tangent line. Okay, so let's break into a new sketch here. We'll just redraw that picture that we had going on there, and then we'll figure out the slope of PQ from there. Okay, so our coordinates were x and x plus h for the x coordinates, and they were f of x and f of x plus h for the y coordinates for those 2 points. So there's P, there's Q, and we're talking about this line segment between those 2 points. Okay, so slope of PQ, as usual, going to be rise over run. So let's look at the rise over this line segment here. So that's the difference in the y values. We'd say it's f of x plus h minus f of x. Okay, and then let's think about the run. So that's the change in our x coordinates here. So that would be x plus h minus x. Okay, and we could actually simplify that. Let's simplify that in our next step. So the numerator is not going to simplify. We'll just call it f of x plus h minus f of x, but the x plus h minus x will definitely simplify. That will become h. So let's come back to our previous page there. So we've now figured out that the slope of PQ, could call it m sub PQ if we wanted to give a notation for it. We figured out that it is f of x plus h minus f of x over h. Okay, so here's the idea. This is how we're going to bring the slope of the tangent line into the discussion. So let's imagine that we had a curve like this, and we want to talk about the slope of the tangent line at a certain point on that curve. Okay, so let's say at that point on the curve, we want to figure out slope of our tangent line. So what we could imagine is the fact that we've actually got 2 points. Let's say this one's P, and let's say we've got a nearby point Q. Okay, so we can think about the line segment, the slope of the line segment between P and Q. And the idea is that as Q slides over and gets closer and closer to P, imagine our point Q moving over this way, getting closer and closer to P, then the slope of this line segment PQ is going to approach the slope of the tangent line. So formally what we're saying is that as h goes to 0, remember h is this small positive number that really represents the difference in the x coordinates between P and Q. So as h goes to 0, that's like saying as Q slides over closer and closer to P, then the slope of PQ is going to approach the slope of the tangent line. So here's the big formula for this section. Let's make a note of it here. So slope of the tangent line, which we're writing m tan, it is the limit as h goes to 0 of that expression that we calculated, f of x plus h minus f of x over h. So that's the key formula that we want to be really familiar with for this section, and we'll use that in 3 examples coming up. So here's our first big calculation example. We want to find the slope of the tangent line to the curve y equal x squared plus 5 at the point where xy is equal to 1, 6. Okay, so let's break into a new page and try that. So anytime we want to calculate the slope of the tangent line, we would start with the formula limit as h goes to 0 of f of x plus h minus f of x all over h. And if you've got a specific x value that you're working with in the problem, then you could sub that in at this point. So in our problem, x was equal to 1. Let's look back and just confirm that. Yep, we're talking about the point xy equal to 1, 6. So x is equal to 1 for the purpose of this calculation. That means we can just sub that in. So we're talking limit as h goes to 0 of f of 1 plus h minus f of 1 all over h. Okay, next thing we can do is get specific about which function we're actually working with in the problem. So let's flip back and see that. Our curve has the formula y equal x squared plus 5. Or more usefully here, let's think of that y as just another name for f of x. We're saying the function f of x that we're working with in this problem is x squared plus 5. So if you wanted to calculate something like f of 1, you just sub in the x value 1, you'd get 6. If you wanted to calculate something like f of 1 plus h, then you want to look at your formula here for f of x, and you want to replace every x that you see with a 1 plus h. So you'd have 1 plus h all squared plus 5. Okay, so that's what we're going to do. We're going to take this stuff, sub it in, and continue with our calculation. So we've got the limit as h goes to 0 of 1 plus h all squared plus 5. So that's our f of 1 plus h right there. Then we're going to subtract off f of 1, which is 6, and we're going to divide through by h. All right, so let's think about what happens near h equals 0. First thing you could try just doing off the top of your head, you could sub in h equals 0 and see what happens. Well, you'd get 0 on the top because you'd have 6 minus 6, and you'd have 0 on the bottom. So you've got 0 over 0, meaning we can't evaluate this limit just by subbing in h equals 0. And that's because this quantity here, this whole thing, see, it's not continuous at h equals 0 because we've got that h in the denominator. So what that means is that we're going to have to do some more algebra. So we're going to do some algebra until we get away from this 0 over 0 expression, and then we'll have our answer. Okay, so let's work on expanding the numerator here. So if we expand the numerator, we'd have 1 squared, which is 1, plus 2 times 1 times h, so that's going to be 2h, plus h squared, so we're just expanding out that square there, plus 5 minus 6, and then that's all over h. Great, so already we've got a little bit of cancellation that can happen there. The 1 plus 5 minus 6, that all gives us 0. So we're looking at 2h plus h squared on top and just an h in the denominator. So this is now a perfect setup for factoring because we can factor an h out of the top and the bottom. So on top, if you factor out your h, you'd have 2 plus h in the brackets, and then we've still got this factor of h on the bottom, which we can think of as like h times 1. Okay, so that means we can cancel a factor of h now from the top and the bottom. And notice that each step we're keeping that limit expression on there. So we're still talking about limit as h goes to 0 of, it's now 2 plus h over 1, or in other words, just 2 plus h. Okay, so notice at every previous step here, if you had plugged in h equals 0 here, you'd have 0 over 0. If you plugged in here, you'd have 0 over 0. It's now just at this most recent step here, after we've done this cancellation, that we're now starting to get a function that is continuous at h equals 0. So as soon as you're able to plug in h equals 0, you can do that. And when you plug in, you drop your limit expression. Don't need that anymore. And subbing in h equals 0, we get 2. So as h goes to 0, the expression 2 plus h approaches the value of 2. So that is giving us the slope of the tangent line to our specific curve at that specific point. So let's look back at the question, just understand what we just did. So let's draw a picture here. You can see the picture that we've got at the bottom of the screen. So our function is the parabola y equal x squared plus 5. So made a quick sketch of that here. Just highlighted a few points on that parabola and then drew that in there. And we were specifically interested in the point xy equal 1, 6. So we can highlight that on our sketch. So the point where x equals 1, right there. And then just eyeballing this, let's think about what we think the slope of the tangent line would be at that point. Well, our calculation indicated that the slope would be 2, and I would say, yeah, that's reasonable based on our sketch. So that's what we're doing when we calculate the slope of the tangent line, and we've now seen how to actually go through that calculation and find the slope. So we're going to do 2 more examples along those lines, really just to practice the algebra behind the process of finding the slope of the tangent line. So next problem, let's find the slope of the tangent line, or mtan, we might call it, to the function y equal x squared plus 4x. So notice that in this example, we are not given an x value to work with. So we will be seeing x's as we go through our algebra, and we'll just practice that sort of process. So just write down for reference what our function is. So it's y equals x squared plus 4x, and the problem is to find the slope of the tangent line. So anytime we're finding the slope of the tangent line, we're going to start off with the formula, which says it's the limit as h goes to 0 of f of x plus h minus f of x all over h. If you had an x value given in the problem, you would sub it in here, but we don't. So it's more about evaluating the f of x plus h and the f of x. So let's do that on the side before we pick up with our calculation. So I'll just make a little box here so that we can do the side calculation. So our function, which you could call y, or maybe better call it f of x, is x squared plus 4x. And we need to figure out what f of x plus h looks like. So f of x plus h is what you get when you replace every x with an x plus h. You'd have x plus h all squared plus 4 times x plus h. Okay, so that's what we're going to be subbing in, and then we can go back to our calculation from there. So we've got the limit as h goes to 0 of, well, f of x plus h is x plus h all squared plus 4 times x plus h, and then we're subtracting off f of x. If you're subtracting off a quantity that has 2 or more terms in it, we just want to be careful that we're putting brackets on there because both of these need to be subtracted off. So we'll need to be careful about our signs, in other words. So we're taking all that stuff and we're dividing it by h. Okay, now you can check if you want what happens if you sub in h equals 0. You're just going to get 0 on top, and you're going to have 0 on the bottom. So we've still got 0 over 0, meaning we've got some algebra to go before we can make sense of this limit. So let's start to simplify just by expanding out the numerator. So expanding the x plus h all squared, we'd have x squared plus 2xh plus h squared. We'd have plus 4x plus 4h, and then minus x squared and minus 4x if we watch our signs. Okay, and that's still all over h. So let's see what kind of cancellation we can do here. We've got x squareds that are going to cancel, and we've got the 4x that's going to cancel. Great, so we've got something quite a bit nicer now. I'm going to clean that up. We've got the limit as h goes to 0 of 2xh plus h squared plus 4h, and that's all over h. So the beautiful thing to notice here is that in the numerator, see, every term has an h in it, and that's the indication that factoring is going to be our next step. Okay, so let's try that. Limit as h goes to 0, pull an h out of the numerator, and we'd have 2x plus h plus 4, and that's all over h. Great, so now that we've got the numerator factored, we can cancel that factor of h from the top and the bottom. That denominator was really like h times 1, so that's just leaving us with a 1 on the bottom. And we can clean this up. So we got limit as h goes to 0 of our expression has become 2x plus h plus 4. That's all over 1, so we don't need to write that over 1 there. Just 2x plus h plus 4. And this is the very first step where it now makes sense to plug in h equals 0, because this expression here is continuous at h equals 0. So you can drop the limit sign. You don't need that anymore, and you can actually sub in, and you'd have 2x plus 4. So 2x plus 4 tells us the slope of the tangent line to that specific curve at any point on the curve. So let's go back to our problem here, and we can actually draw a picture. Okay, I think there are a couple other x values that I'm interested in, so I might plug those in down here. So let's try x equal -2, x equal -4, and we'll actually make a sketch of this curve and just convince ourselves that that looks right. So if x were equal to -2, then slope of our tangent line, just plugging in here, would be 0. And if x were equal to -4, slope of our tangent line would be -4. Okay, now if we wanted to sketch this curve just to see whether that seems reasonable, let's make a quick table of values here. So I think some nice x values to plug in would be 0, -4 would be a nice value to plug in, and -2 would be a nice one. And I think we'll see why when we draw our sketch of our parabola. Incidentally, we'll talk more about curve sketching a little bit later in the course, but the point of this here is just to get a visual on what we just did. Okay, so table of values, remember what we're trying to plot here is that curve that we were starting with. So y is equal to x squared plus 4x, and subbing in, we'd have 0 at the x value 0. We would have -4 when x is equal to -2. And we would have 0 when x is equal to -4. Okay, so let's make a quick sketch of that. We're going to need to go as far down as -4. And we're going to need to go as far left as -4. So I'll just label the axes there so that we've got a nice sketch going. And let's just plot these points. Okay, so when x equals 0, y is equal to 0. When x equals -4, y is equal to 0. And when x equals -2, we're down here at -4. Okay, so our parabola Looks a little something like that. So now let's see whether these slopes are reasonable. So we said when x equals 0, slope of the tangent line would be 4. Okay, that seems reasonable. When x equals -2, slope of the tangent line is 0. Yep, that's right, because that's corresponding to the vertex of the parabola. So at that point, the tangent line will just be horizontal, so it'll have the slope of 0. And when x equals -4, we're talking about that point there on our graph. Yes, the tangent line would have a negative slope. -4 seems reasonable. So similar kind of problem as before, just a little bit more practice with the algebra. Let's find the slope of the tangent line to the curve y equal 2x squared minus 6x plus 3. So I've written down the function in the top right here just so that we've got that as a reference, and we're going to go about finding the slope of the tangent line. So we'll start by saying it's the limit as h goes to 0 of f of x plus h minus f of x all over h. If we had an x value, we would sub it in at this point, but we don't. And then next thing to do is just to sub into our function. So we really need to figure out what f of x plus h is equal to, given that the function that we're working with has this formula up here. So instead of calling that y, let's call it f of x. Okay, and just think of that as a reference from the problem. So now we need to figure out what f of x plus h is. Okay, so we're going to replace every x that we see with an x plus h. We'd have 2 times x plus h all squared minus 6 times, we're going to need brackets, minus 6 times all of x plus h, and then plus 3. Okay, so that's what's going to be going in to the first term in the numerator inside our limit expression. So let's try that. So we've got limit as h goes to 0 of all this stuff here, 2 times x plus h all squared minus 6 times x plus h plus 3. And then looking back at our expression here that we're subbing into, we still need to subtract off the f of x. So we need to subtract off, I'm going to give myself brackets here, 3 terms are getting subtracted off, the 2x squared, the minus 6x, and the plus 3. Okay, and then that's all over h. So let's do some algebra until we get to the point where we can sub in h equals 0 and get something that's not 0 over 0. So we'll just start expanding this. At every step, we're going to keep our limit expression on there. Okay, so let's start by leaving the 2 out in front, and we're just going to expand the square. So we'll have x squared plus 2xh plus h squared. Distributing the -6, we'd have minus 6x minus 6h plus 3. And then we're going to have sign changes across the square bracket. So minus 2x squared plus 6x and minus 3. Okay, and then that's all over h. So at this point, we should have some cancellation that can happen. The minus 6x and the plus 6x will cancel, and the plus 3 and the minus 3 will cancel. So that's looking good. Okay, continuing with this, we've got limit as h goes to 0. Let's distribute the factor of 2 there. So 2x squared plus 4xh plus 2h squared. Still got our minus 6h, and we've still got a minus 2x squared. Okay, and then that's all over h. So another little bit of cancellation, the 2x squared and the minus 2x squared will cancel. And now we're in this nice place where every term in our numerator has a factor of h in it. Okay, so it's factoring time. We got limit as h goes to 0 of h times 4x plus 2h minus 6, and that's all over h. Okay, so the point here is that the factor of h going to cancel from the top and the bottom. And if we clean this up, we're talking about limit as h goes to 0 of 4x plus 2h minus 6. So this is the very first step now where it makes sense to plug in h equals 0 we're getting something other than 0 over 0, so that's beautiful. At the point where you're going to actually sub in, you no longer need your limit sign, and you now just replace the h with the 0. So we're getting 4x minus 6. So that gives us the slope of the tangent line at any given point to the function that we started with, which was this guy up here. So let's go back to the question and just confirm that we've done that correctly. Okay, so we've seen what a tangent line is. We've seen the key formula for how to calculate the slope of the tangent line, and then we did 3 examples to practice that calculation. So we can now find the slope of the tangent line to any curve that's given to us at any point on that curve. Thanks for watching.